Today we're going to look at an example of testing the difference between two samples, but this time they are dependent samples. So there's like a before or after kind of set of information. Somehow the two samples are linked together. So let's go ahead and get started. A random sample of 6 music students played a short song. The number of mistakes in the music each student made was recorded. Then they practiced the song 5 times, and the number of mistakes a student made was recorded again. So our sample is before they practiced and then after they practiced. And each set, the before sample and the after sample, is linked to an individual student. So these are dependent samples. Let's see, the data are shown at alpha equals 0.01. Can it be concluded that there was a decrease in the mean number of mistakes? Assume that all variables are normally or approximately normally distributed. Well, we have samples that are dependent, and we're told that since we have such a small sample size that it's okay to assume they're approximately normally distributed. So we can use a t-distribution. And that's going to be important to us in a minute, because what we're going to need to do is use a t-distribution just like we did back in the one sample, back in chapter 8. But this time we're testing something different. We're testing the difference between the before and the after. So these types of problems, literally what I like to do is come up and draw, looking for another color, and draw another row and call this row the D row, the difference between x1 and x2. So I would take 12 minus 1, which is 1, 14 minus 12, so 2, and then I have a 4 and a 1 and a 1, and 8 minus 13, so let's see, minus 5, I believe. And I would make this new row of information, and this new row is what I'm going to use for my statistics, for my testing, for my t-distribution. Now I can do this in my calculator really easily, and we'll do that right after we write the hypotheses. So my hypothesis, let me switch back to regular color. So we have the null hypothesis, that the difference is equal to 0. So notice I have this new notation. I have the mean of the difference is equal to 0. And then my alternative is that the mean of the difference is actually greater than 0, because my claim is that I'm testing that I'm testing that them having practiced the song, that the difference is greater than 0. That before minus after is going to be greater than 0. So that these after mistakes are going to be smaller than the before mistakes. So the difference between them is going to be greater than 0. Sometimes this is kind of tricky for students to see. If it's difficult for you, you can think, okay, if my first sample minus my second sample is greater than 0, I can add x2 to both sides, so x1 is greater than x2. So what I'm saying is that the before mistakes are greater than the after mistakes. That's the same thing as saying that their difference is greater than 0. And that's what we're testing. So I'm going to use my calculator to make sure that I don't make any mistakes. So I'm going to go ahead and flip over to my calculator. I have no clever way of showing this to you outside this. I put the before in list 1, and I put the after in list 2. And I want to go ahead and subtract my list 1 from my list 2, because that's my new set of data that I'm going to be running my t-distribution on. My t-test on, I should say. So what I'm going to do is I'm going to go ahead and arrow over to list 3. I'm going to arrow up until I'm on top of list 3. And what I want in list 3 is I want L2 minus L1. So I'm going to hit my second button and then the 1 key. So second, and then the 1 key. And notice that it's saying list 1 down here minus the second and the list 2 key. And I'm going to hit enter. So here we have all of the numbers that I wrote down when I made that third column. So here we go. These are the numbers that we're seeing, right, in list 3. So I'm going to come back to list 3, and I'm going to do a one sample t-test on list 3. So let's see here. I'm going to go to statistics, and I want to go over to test, and I'm going to do a t-test. I have one sample of data. The sample is the difference, but it's one sample of data. So number 2 is t-test. I'm going to hit enter, and it's going to say, do you have data? Yes, I do. Where is it at? What are you testing against? 0. Sorry, it takes a minute to adjust. Where's your data at? It's in list 3, so I'm going to go down to list 3. So second, number 3 to get in list 3. Enter. The frequency is 1. Your alternative is greater than 0. So here we go. All right, so our alternative is greater than, that's highlighted, and then we're highlighted on calculate. So when we get done filling in our formulas, we should have some stuff that agrees with this. Our test statistic should be approximately 0.542326. Our p-value should be 0.305 approximately. The x-bar of the difference should be 0.667, and the standard deviation of the difference should be 3.06. And we have 6 matched pairs. We have 6 pairs of observations. So we just did the one sample t-test in our calculator, which is very similar to what we're going to do by hand. All right, so we have our hypotheses. Let's go ahead and write our test statistic. So our test statistic, I'll make those capitals. That's what I've been doing so far. We're going to use the t-distribution again because we do not have any population standard deviation given, and because our pairs are dependent. And then we're also told that we can assume that it's normally distributed. So the t-distribution is fair for us to use right now. So we have t is equal to d bar minus mu d all over sd divided by the square root of n. All right, so d bar would be the sample average of my differences, which we found to be 0.6667. Mu d, as we look back up at our hypothesis, equal to 0. The standard deviation, which we got from our calculator, we could have done one variable statistics, and we could have got the sample standard deviation to be 3.01109 divided by the square root of 6 because we have 6 samples. When we plug that in our calculator, we should get approximately 0.5423. Okay. Now we're going to go ahead and use our p-value method. So p-value. And just to recall right here, we have a right tilde test. It's going to be important because we're going to only shade the area to the right of our test statistic. And so since we're using the t-distribution, we should be able to go t, c, d, f. Our lower limit is going to be this positive 0.5423 up to infinity. Our degrees of freedom is going to be 1 minus the number of samples we have, which is 5. And that should be equal to 0.30544. So we have a pretty big p-value. We do not need to multiply it by 2 because, again, we have a one-sided test. So this is going to imply that we're going to reject. No, it's not. This p-value is larger than our alpha, so we are going to not reject. So do not reject H0. So if we go back up to our hypotheses, if we do not reject this, then we do not have evidence to support the alternative. So we do not have evidence to support that the difference between the before and after was statistically significant. So let's write our summary. At the alpha equals 0.1 level, let's Yeah, 0.01 level. At alpha equals 0.01 level, we do not have evidence or enough evidence to support the claim that the average difference, that the average difference between the before and after groups is greater than 0. So what that tells us is that practicing the song, if we look back up here, that practicing the song doesn't mean necessarily, we don't have evidence to support that just because they practice a song that their number of mistakes went down. So this, what we could be seeing here could be by random chance, that we cannot support the claim that practicing the average number of mistakes went down. Alright, so as we can see, this is very similar to what we did in Chapter 8. We essentially did a one sample t-test, but our first step was that we had to find the difference between the before and the after group. Then we did a one sample t-test on the difference. And I'll say that everything else that we did was exactly the same as Chapter 8. Feel free to email me if you have questions.